Well, our next uh, topic, total pressure on an inclined immersed surface. That means the surface is immersed in an inclined way. That is immersed in an inclined way. So we will check how to find out the equation for total pressure force when the object is or when the surface is immersed in an inclined way. Okay. The same way, consider a vertical surface of arbitrary shape is immersed in a liquid in such a way that the plane of surface is inclined to the surface of the liquid. That means the surface of the object is inclined to the surface of the liquid. The same way we did it, in a vertical and horizontal case. We'll take a small strip of thickness dx here also, and width b at a distance of h from O. That means from the free surface, the strip is at a distance of h. O is a point on the liquid surface where the immersed surface will meet if produced. And because the surface is inclined, if we produce it backwards, that will meet the liquid surface at the point O. So distance from O to that strip is h. Okay. And now we'll calculate the intensity of pressure on the strip. P is equal to rho g h into sine theta. We have to construct a triangle for that. So we'll get rho g into h sine theta, h into sine theta. Sine theta means opposite by hypotenuse. That we can see from the triangle. If you construct a triangle, you can see that what is sine theta. Sine theta means opposite h by hypotenuse. Hypotenuse. Okay. From the triangle, h is hypotenuse and h bar will be the opposite side. So that will look later. Now we'll go for area of the strip. dA is equal to B into dx. Total pressure force on the strip dP is equal to intensity of pressure into area of strip. That means rho g h sine theta into B dx. If you want to be clear about sine theta, okay, you have to construct a triangle. It is not shown in the diagram in your book. You have to do that. Then you can find out what is sine theta and all. Okay, here rho g h sine theta into B dx. So total pressure force on the surface will be equal to integral. You have to integrate it. That is integral rho g h sine theta into b dx. That is rho g sine theta into integral h into b dx, because rho g sine theta is constant. So integral h into b dx. Integral h into b dx is equal to moment of the surface area about point O on the liquid surface. If you calculate the moment of the surface area about that point, that will be integral h into b dx. That is AH1. AH1 we can calculate. AH1 is equal to AH bar by sine theta. AH1 is equal to AH bar by sine theta. H1 is H bar by sine theta. From the diagram we can see that H1. H1 is the distance of the center of gravity of the total surface from the point O. That is H1. So if we construct a triangle like that, sine theta is equal to H bar by H1. If you calculate, if you make the triangle with the strip, then it will be h bar by h. When the whole body comes, or when the whole surface comes, it will be h bar by h1. So h1 is equal to h bar by sine theta. So we can see that ah1 is equal to h bar by sine theta. So total pressure on the surface P is equal to rho g sine theta into h bar by sine theta. Sine theta on the above and below of the division line will cut off, and now you will get the result rho g h bar. Again the same equation for vertical, horizontal and inclined side, inclined position. We get the same equation, that is rho g h bar w h bar. So you have to bear in mind that all the three cases, when the object is immersed vertically, horizontally or at an inclined position, the equation remains the same to find the total pressure force on the surface. It is the force and not the pressure. So the unit will be in Newton. Okay. Now we'll move on to next topic, that is Archimedes principle. Archimedes was a Greek scientist, he mathematician. He described this principle. based on the buoyant force. So we'll see what is Archimedes principle states that when a body is completely or partially immersed in a liquid, the liquid exerts an upward force, that is buoyant force, on the body equal to the weight of the liquid displaced by the body. What is that? Buoyant force. We will discuss buoyant force. Buoyant force means when a body is completely or partially immersed in liquid, the liquid will exert an upward force on the body, that is called buoyant force. So based on the buoyant force, Archimedes discovered this principle. Okay, there is a story behind that I will detail you in our live class. Okay, and now just try to understand that when a body is completely or partially immersed in liquid, the liquid exerts an upward force. That means the liquid try to uh, rise the object. Okay, uh, rise the object with a force equal to the weight of the uh, liquid displaced. When the body gets immersed in the liquid, some liquid will be displaced, then the weight of the liquid will be equal to the buoyant force on the body. Okay, now that is Archimedes principle. Buoyancy. Next term is buoyancy. It is an upward force exerted by a liquid that opposes the weight of a partially or completely when the object is completely or partially immersed in a liquid, and the liquid will exert an upward force, that is called buoyancy. You can see the diagram here. That is Archimedes principle is clearly shown from this diagram. We can make it out. Okay, first one, the object starts getting immersed. The second one, object is partially or full half portion is immersed. Then third one, object is completely immersed. From the three diagram, we can see that liquid level is rising. From left to right, the liquid level increases, and when the object is completely immersed, liquid level is the highest. Okay, so that means that when the object goes inside, the liquid goes up. Okay, but one thing you have to make that lots of application is there with this Archimedes principle. That means when a body gets immersed in a liquid, whether it is partially or completely, the liquid will be displaced, and the amount of liquid will be displaced will be equal to the uh, a force on the a force or buoyant force on the object. That is, the weight of the liquid is equal to the buoyant force exerted by the liquid on the immersed body. See, uh, with this diagram it will be more clear to you. You can see that when the object weighing 10 kilogram is immersed in the liquid, it weighs lesser. You can see from the diagram. That means because of the buoyant force exerts an upward force on the body naturally, that will cause the reduction weight of the object. Okay, from the left image you can see that it weighs around 10 kg. The object is 10 kg, and the balance shows 10 kg, but when it is immersed in the liquid, it weighs is reduced. Okay, therefore because this 10 kilogram object displaces 4 kilogram of water, because that object displaces 4 kilogram of water, then that will weigh only 6 kilogram underwater. Okay, buoyant force is equal to the weight of the displaced water. This diagram, I hope it will make you clear more about Archimedes principle. So next is center of buoyancy. Center of buoyancy, it is a point through which the buoyant force is supposed to act. And the point through which buoyant force acting is called center of buoyancy. Since the buoyant force is vertical force, that means the liquid acts upwards. Liquid force is acting upwards, so that is vertical and is equal to the weight of the liquid displaced body. As per Archimedes principle, the buoyant force acting on the object immersed in a liquid is equal to the weight of the liquid displaced by the body. So point of action of buoyant force is the center of gravity of the liquid displaced. You can see that the point of action of buoyant force, that is center of buoyancy, is the center of gravity of the liquid displaced. Okay. Next one is meta center. These are the important time related with the floating bodies on liquids. Okay, it is defined as the point about which the body starts oscillating when the body is tilted by a small angle. When a body is floating on a liquid, if we give a small tilt onto it, the point about which body starts oscillating, that is called metacenter. Can also be defined as the intersection of line passing through the original center of buoyancy and the center of gravity of the body, and the vertical through the new center points. Okay, before tilting the body, there is a line passing through the center of buoyancy and center of gravity, and after tilting the body, the center of buoyancy will change. So those two lines, the line passing through center of gravity and center of buoyancy before tilting, and another vertical line through the new center of buoyancy, its meeting point, meeting of both the lines, also called metacenter. Metacentric height, it is the distance between center of gravity of floating body and the metacenter. Okay, metacenter is the uh, point about which body starts oscillating, and center of gravity is another point. So distance between center of gravity and the floating body and the metacenter is called metacentric height. Here you can see two diagrams. First one, before tilting, the center of gravity and center of buoyancy lies on the same line. So M is shown above, that is metacenter. In the second one, the body is tilted. So the vertical lines M, G, B, that is center of buoyancy, center of gravity and metacenter is shown on the left side, and on the right side a new line is formed, that is center of buoyancy position is changed. So the line passing through metacenter and center of buoyancy, we can see that the first line, that is line passing through center of gravity and center of buoyancy, meets with the second line, that is the new center of line passing through the new center of buoyancy meet at point M. M is the metacenter. Now, stable equilibrium and unstable equilibrium, neutral equilibrium can be classified into three. First one is stable equilibrium. When the metacenter is above the center of gravity, that means M is above G. We find that on giving a small tilt to the floating body, and the upthrust will form a righting couple. Okay, the upthrust means the buoyant force. Okay, the force trying to restore the body back to its normal position, that is called the upthrust, that is forming a righting couple. Okay, when we give a tilt, that tilt will cause the body becomes imbalancing, that will turn. Okay, but the liquid will exert an upthrust, that will try to bring the body back to its normal position, that is called these two forces together form a righting couple, that is restoring couple, to bring the body back to its initial position. Then the body is said to be in equilibrium. That means even after giving a tilt, if the body regains its original position, then it is called stable equilibrium. Then next one is unstable equilibrium. That is when the metacenter is below the center of gravity. Earlier case, it was the metacenter was above the center of gravity. Here, when the metacenter comes below the center of gravity, we find on giving a small tilt to the floating body, the weight of the body and the upthrust will make the body tilt further. That means after tilting, the body will tilt further, and it will turn upside down. Okay, the body will not therefore be restored to its earlier position. Then the body is said to be in unstable equilibrium. Okay, here three diagrams are shown. First one is stable. Here center of gravity, center of buoyancy you can see. Okay, the second one is stable equilibrium, that is metacenter is above center of gravity. So the boat will regain its original position even after tilting. The third one is unstable equilibrium. Here metacenter comes below the center of gravity after tilting. Okay, the righting couple cannot take it back to the original position, so it will turn upside down. So these three are three equilibrium: stable, unstable, and the first one is neutral. That means no tilting is given. Okay, that is for the day. So next portion I will upload and inform you as and when it is done. Thank you.